notion of an algorithm. Further, we'll explain Padmashri.
First of all, what is an algorithm? An algorithm is finite, a well-defined, step-by-step logical procedure used to solve a problem or perform a computation. It is independent of any programming language and focuses purely on thinking and reasoning. The notion of algorithm emphasizes clarity of steps, correctness of outcome, and efficiency of execution. In real life, algorithms exist everywhere, making a tea, booking a train ticket, and deciding the shortest route to the college. These activities follows a sequence of decisions and actions, which reflects algorithmic thinking even without computers. Why algorithm matters? Algorithms form the foundation of computer science. Competitive exams like GATE and industry problem solving, companies such as Amazon, Google, and Infosys evaluate candidates based on how they think algorithmically, not just how they code. Further, will explained by Abhinav.
Design thinking overview. Why use design thinking for algorithm? Traditional algorithm learning focuses on formulas and steps. Design thinking adds a human-centered problem-first approach, making algorithm easier to design, understand, and apply to the real-world scenarios. DT stages used in algorithm designs. Empathy. To understand the real problem and user needs. Define. Clearly states the problem in an algorithmic terms. Ideate. Think of multiple logical solution strategies. Prototype. Conceptually structure the algorithm steps. Testing is implied through validation, but no coding is involved here.
As defined in the case study, Smart Traffic Signal Management System. Problem context is a metropolitan city faces heavy traffic congestion during peak hours, causing delays, fuel wastage, and increased pollution. Traffic signals operate on fixed timers, ignoring real-time traffic density. The city administration wants a logical, step-by-step solution to optimize traffic flow without immediately implementing software. This scenario requires algorithm thinking.
Empathy and define stage. Empathy stage. Understanding the problem deeply. Different roads have different traffic volumes. Peak hours vary by location. Emergency vehicles need priority. Pedestrians must be considered. The focus is not on signals but on the people using the roads. Define stage. Algorithmic problem statement. Design a finite and logical step-by-step process to control logic traffic signals dynamically based on traffic density, priority vehicles, and time of delay, ensuring smooth traffic flow. This converts a real-world issue into an algorithmic problem with inputs like traffic density, time, vehicle type, constraints like signal rules, safety, and output is optimized signal duration.
Ideate, thinking of algorithmic strategies. Multiple solutions ideas are explored without implementation. Sequential decision making based on traffic density, conditional prioritization for emergency vehicles, repetitive monitoring at fixed intervals, comparison based on decisions between lanes. This stage reflects core algorithm concepts like decision making, iteration, condition checking, logical ordering of steps. No single solution is chosen immediately. Alternative logical paths are evaluated, which is a key skill tested in GATE and interviews.
So the nice presentation. Next, further we'll explain Pachinagi. Pachinagi, can you explain prototype for this notion of an algorithm?
So in prototype stage, conceptual algorithm structure. At this stage, the algorithm is mentally structured as start with traffic observation, evaluate conditions, decide signal duration, apply changes, repeat the process. This is the conceptual prototype, not code. It ensures the algorithm is finite, unambitious, effective, and efficient.
So the conclusion is, in conclusion, the section has clearly demonstrated that the notion of an algorithm goes for beyond writing code for following predefined steps. Through a design thinking approach, we learned that effective algorithm design begins with empathy, where understanding the real problem and the people affected by it becomes the foundation of every solution. By focusing on user needs and real-world constraints, we move away from abstract thinking and instead design algorithms that are practical, meaningful, and adaptable to real situation. As we progress to the defined stage, we realize the importance of clearly framing the problem in algorithmic terms. Many real-world challenges fail not because of pure solution, but because the problem itself is not properly defined. Design thinking helps us convert a complex real-life scenario into a structured problem with clear inputs, constraint, and expected outcomes. This step is crucial in algorithmic problem solving, especially in competitive exams like GATE and industry interview, where clarity to thought is valued more than memorization. During the ideate stage, we explored multiple logical solution paths without immediately jumping to implementation. This stage emphasized that there is rarely a single correct algorithmic solution. Instead, there are multiple approaches, each with its own trade-off. Evaluating these alternatives strengthened our analytical thinking and decision-making abilities. This real industry practices where engineers compare efficiency, feasible, and impact before finalizing a solution. Prototypes allow us to conceptually structure the algorithm as a sequence of logical steps without writing code. They reinforced the idea the algorithmic should first be mentally validated for correctness, completeness, and efficiency. By building a conceptual prototype, we ensured that the solution was finite, unambiguous, and effective. Key characters of good algorithm. These steps also highlighted how design thinking reduces error by identifying logical gaps early in the problem solving process. Thank you.